Maintenance includes a long list of activities that will vary depending on the size and the technology of a treatment plant. In general, operation refers to all activities that ensure that a treatment plant delivers treatment as designed. Activities to ensure the operation of a treatment plant starts with coordinating the sludge discharge. This typically includes reporting the sludge volume and origin and payment of the discharge fee by the collection and transport service provider, and coordination of the sludge discharge by the private or public utility managing the treatment plant. This is shown here at the fecal sludge treatment plant in Kampala. Many other activities are associated with the operation of treatment technologies. This, for example, includes cleaning of screens at the inflow of settling thickening tanks or drying beds, and also disposal of the solid waste. Another example is the cleaning of inlets and outlets, for example at waste stabilization ponds, as shown here. Other examples are the loading and unloading, for example of settling thickening tanks, or of drying beds, or the turning in co-composting. Also, treatment products need to be managed. Here you can see workers of a treatment plant loading sludge from a drying bag on a truck of a farmer for use as soil conditioner in agriculture. For more formalized resource recovery from fecal sludge treatment products, this can also include other activities, for example bagging of the resource recovery product, for example of compost, or marketing. For example, includes records on the sludge volume that is discharged at a treatment plant. This is important to assess whether the treatment plant receives more or less sludge than designed, and this will affect the performance of the treatment plant. In addition to records on the sludge volume, characteristics of fecal sludge discharged at a treatment plant and of treatment products from treatment technologies can be used to estimate the treatment's performance. So for example, the settling thickening efficiency in a settling thickening tank can tell you how good that settling tank is operating. Also, other process parameters such as temperature in co-composting can be important. In co-composting, the temperature can be an indicator for pathogen inactivation. Such information is also helpful to optimize the treatment plant and potentially increase its treatment capacity. Monitoring of a treatment plant is also required to assess the quality of treatment products before its use, especially pathogens such as E. coli in helmet eggs, and to report to authorities on discharge concentrations. These include, for example, chemical oxygen demand, suspended solids, and ammonia and nitrogen. In addition to recording the sludge volume and characteristics and to process parameters, a manifest system can be a useful tool for a treatment operator. Let's have a closer look. The manifest form has to be filled out during the collection of fecal sludge by the service provider. It includes the name and other details of the client, and it also includes the type of on-site sanitation technology from which the sludge is being collected. In this case, from the Philippines, only septic tank fecal sludge is collected, but it can also include other sludge types such as pit latrine sludge or sludge from public toilets. The manifest also indicates if the sludge is collected from residential, commercial, industrial, or institutional on-site sanitation technologies. The manifest form then also includes details on the service provider. Following completion of the collection service, the manifest form has to be signed by the client. Upon arrival at the treatment plant, the treatment operator has to approve this manifest form in line with the capacity of the treatment plant. This could be a way to identify industrial contaminations, for example when sludge from industries is delivered. The contribution of sludge from different on-site sanitation technologies, so for example septic tank versus pit latrines, could also be important as it has implications for treatment. For example, the solid-liquid separation efficiency on drying beds or in settling thickening tanks. The system should always be complemented with visual observations such as the sludge color. Any other color than brown or black could indicate industrial contaminations which could disrupt the treatment operation. A signature of this manifest form by the treatment operator could also be a proof to the client or a government authority that the service provider discharged a legal location. Maintenance activities ensure the long-term operation of equipment and infrastructure at the treatment plant. This, for example, includes physical inspection of servicing of pumps or tractors or backup generators that are relevant for settling thickening technologies, or the replacement of sand filter layer or roofs for drying beds. This means that operation and maintenance are interlinked. Suboptimal operation can increase the maintenance, for example by the failure of pumps, and suboptimal maintenance will likely lead to poor operation. Every fecal sludge treatment plant should have operation and maintenance plans. In general, operation and maintenance plans document the procedure of the operation and maintenance activity. It also includes tools that are required to conduct the activity, and show how often the activity has to be performed. It also includes performance indicators to measure if the activity was successful, and includes health and safety precautions. Such precautions should prevent employees from getting sick, for example from pathogens or electrocuted from electrical devices. An example of an operation and maintenance plan are standard operating procedures for the analysis of fecal sludge. These can be downloaded for free of charge from our website. Documentation of the operation and maintenance activities documented in these operation and maintenance plans in logbooks and data summaries are really important for internal and external reporting and decision making. Operation and maintenance needs to be performed once the treatment plan has been designed and constructed. But it is really important to consider these activities at the early planning stages of a fecal sludge management program. Otherwise, treatment plans can fail. Let's take this example of a settling thickening tank. If a pump for sludge removal cannot be operated due to a lack of electricity, or the tank can't be maintained because of lack of funds, the tank will have a poor performance. This will affect subsequent treatment steps and ultimately the effluent concentrations of the treatment plant. In this module, we learned about typical operation and maintenance activities such as coordination of the sludge discharge, cleaning of screens and tanks, and monitoring. A manifest system can be a helpful tool to monitor the sludge discharge into a treatment plant and to identify industrial contamination. These activities should always be documented in operation and maintenance plans. Following these plans will ensure that treatment plants operate as designed and protect public and environmental health, in addition to producing marketable treatment products.